This is section 7.1, part 3. We're trying to solve the system by the addition method. I've already found x, and now I'm going to go back and try to find y by plugging 11 over 2 either into equation 1 or 2. Either one doesn't matter. I think I'm going to choose equation 2. So 11 over 2 divided by 2 minus y over 4 is equal to 1. Okay, so let me deal with 11 over 2 divided by 2. We can write that as 2 over 1, so that'd be 11 over 2 times, okay, flip that, so it'd be 1 over 2, so 11 over 4 minus y over 4. I'm going to go ahead and change this 1 to 4 over 4. Subtract the 11 over 4 from both sides. Okay, and then I will have 4 minus 11 over 4. So that'll give me negative 7 over 4. Okay, and then I'm going to multiply by negative 4. Okay, so the 4's will cancel, the negatives will cancel, and what I'm left with is 7. Okay, so my solution should be 11 over 2, comma, 7. And then you can go back and check just to make sure, plug it back into both solutions and make sure that it does work out to true statements, both of them. Okay, now let's try to solve this one using the addition method. Now all the x and y's should be on one side, they should be lined up, and then the equal sign, and on the other side of the equal sign you should have your constants, which this one's already set up like that. So we can either get rid of the x values or the y values, it doesn't matter. So let's try to get rid of the y values. Okay, so what I'm going to do is I'm going to multiply this equation by 2, and we're going to make that a negative 2. So when I multiply the negative 2 times this negative 2, it will give me a positive 4, and then I'll have a negative 4 here, and then they'll cancel out. Okay, so that will give us negative 6x plus 4y is equal to negative 12. And we have 6x minus 4y is equal to 18. Okay, so we get 0x plus 0y is equal to 18 minus 12. That gives us 6. Okay, so we get 0 is equal to 6. Okay, notice I have no variables left over, and I have a false statement because 0 does not equal 6. Okay, so when I have those two, no variable and a false statement, that means that I have no solution because these two lines are actually parallel. Okay, so these two lines are parallel to each other, and we could look at that. Let me move this right here. So the answer is no solutions. So let me just move this right here, and let's just look at these two. We're going to put them in y equals mx plus b format. Okay, so 3x minus 2y is equal to 6. We'll say equation 1, equation 2. Okay, I'm going to move the 3x to the other side, and then divide everybody by the negative 2. So that gives me 3 over 2x minus 3. Okay, we'll look at 2. 6x minus 4y is equal to 18. I'm going to move that 6x over, and then divide everything by a negative 4. Okay, so negatives go away, and I'm going to take a 2 out of the 6 and a 2 out of the 4, and then minus 18 over 4. I'll take a 2 out of the 18, gives me 9, a 2 out of the 4 gives me 2. Okay, now notice I have the exact same slope for each of these for equation 1 and equation 2, but I have a different y-intercept. Anytime you have the same slope and a different y-intercept, that means that you're going to have two parallel lines. Okay, so these two lines that they gave us here, they are parallel, which means they'll never intersect, which means that we have no solution. Okay, let's look at this one. Let's say that we're going to get rid of the y's. So I'm going to multiply this by 2. So 10y minus 30x is equal to negative 20. And then that's going to be negative 10y minus, oops, sorry, that would be plus 30x is equal to 20. Okay, the y's go away, the x values go away, and this goes away. So I have 0 is equal to 0. Okay, so notice I have no variables, and I have a true statement because 0 does equal to 0. Okay, so that means that I have infinitely many solutions. Now let's look at each one of these, and we're going to put them into y equals mx plus b format. We'll say this is 1, we'll say this is 2. So 10y minus 30x is equal to negative 20. I'm going to move that negative 30 over, and then divide everything by 10. So y is equal to 3x minus 2. Okay, do the same thing for the second one. I'm going to move the 15x over to the other side. Divide everything by a negative 5. So y is equal to, that'll be positive. 15 divided by 5 is 3. Positive divided by negative is negative. 10 divided by 5 is 2. Okay, notice I have the exact same equation. They both have the exact same slope, and they both have the exact same y-intercept. So that means essentially we have the same line, but it's just written in two different ways, but it's essentially the same line. So when you graph this, if you graph a line, so say I just graphed equation 1, and then when you go to graph equation 2, well, it comes out to be the exact same one, just overlapping that one. Let me draw that again. Okay, so here is equation 1, and I go back and I graph equation 2, and it just falls right on top of that one because it's the same line. Okay, identifying inconsistent systems of linear equations containing two variables. So inconsistent systems consist of parallel lines that have the same slope, and this is what I've been talking about. They have the same slope, but different y-intercepts. Therefore, they will never intersect, and therefore, no solution. So looking at this one, we can just put them into y equals mx plus b format. And we'll go ahead and look at, we'll say this is 1, this is 2. So we have x equals 9 minus 2y. And I'm going to go ahead and move 9 over, and then divide everything by a negative 2. Okay, I'm going to switch it around. Y is equal to negative 1/2 x plus 9 over 2. Okay, x plus 2y equals 13. I'm going to move that x over, and then divide everything by a 2. So y equals negative 1/2 x plus 13 over 2. Okay, notice I have the same slope. They're both a negative 1/2, but I have different y-intercepts. Okay, so these are going to be parallel lines, which means you're going to have no solution. Okay. Identifying dependent systems of linear equations containing two variables. So a dependent system is a system in which two equations represent the same line. Since this linear system is describing the same line, there are infinitely many intersections resulting in infinitely many solutions. Okay, So what this will look like, and we're going to go ahead and name this as 1 and 2. We're going to put them both into y equals mx plus b format. So for 1x plus 3y is equal to 2. I'm going to move that x over to the other side and then divide by 3. So negative 1/3 x plus 2 over 3. 3x plus 9y is equal to 6. I'm going to move that 3x over to the other side and then divide everything by 9. So y is equal to negative. Take a 3 out of the top, 1. Take a 3 out of the bottom, 3. Plus. Take a 3 out of the top, 2. Take a 3 out of the bottom. I'm talking about this one right here. Take a 3 out of the 6. Take a 3 out of the 9. Notice it is the exact same line. Okay, so since it's the same line, we have infinitely many solutions.